or in our YouTube channel, so you can check those video and you'll have a broader and better ideas. Now, our
All right.
DevOps evening batch job ready training for 7 weeks is going to start from the next Friday. Same goes for our cybersecurity evening batch for 6 weeks, Monday to Friday, daily 2 hours is going to start from next Friday. So those who have already decided which their path, roadmap, and try to opt out our training, feel free to ping us, call us, or you can join, complete the registration online. Make sense? Okay then.
All right. So I will check the group. Yes, sir.
Sure. Okay, we are on to start for our DevOps session for today. Thank you.
Yeah, I'm just starting my recording, the recording. And again, I will reiterate. The thing is, after a brilliant session like what Karthik had, it will be a bit difficult for me to start a session which is almost related. It is not far away. But the thing is, to get started, a car which has just now finished one big journey, a long journey, okay, it takes a bit of cooling off. Now, I think you already have that cooling off, and I have to start warm up myself. So thank you for giving me this opportunity. We will start our session on Docker. We are stepping into the containerization world. Thus far, we have done a lot of information that we can gather on AWS. Initially, we started with DevOps introduction. Then we started with AWS. And after that, we went to learn GitLab, a CI/CD pipeline. Then we started Terraform and Ansible. And then we did a project demo on using GitLab, the CI/CD pipeline, the Terraform, and the Ansible together. So there's an integration, continuous delivery, and deployment pipelines. So up to this, we have done this. And now we are going into the containerization world. We are going to start with Docker, and we will end up with Kubernetes. Is that fine? Any questions you have? Again, as Mr. Menon had told you, that it is, if you have missed any of the session, you would be fine. You will find all of the session recordings into our YouTube channel. And that link, today only I have given you, there is on our group, there is a pinned message, and you will see that the YouTube link over there. Okay? So you can go there and see all the playlists. So whatever we had on cybersecurity, all the previous seven sessions, and in DevOps, all the 6 sessions. Okay. So let me start sharing the screen. Can you hear me properly? Is the audio and the video?
Yes,
Really
you're
visible?
audible. You're audible and you're vivid, sir.
Okay. So there's a time for me to start sharing the screen. Let me know if sometimes there can be a breakage of networking. So it may happen that my voice is not clear or not audible, or my video is not visible. Do let me know, because I won't find it. So we are going to start the containerization tool, which is Docker. It's very important that you step into this world, because without this, actually, all the automations that we talk about in DevOps, okay, in our processes, in our company, will not happen without understanding containerization. And that is one technology that you need to understand, without which your learning in DevOps is not complete. As simple as that. Okay. So let me know if you can see the screen.
Yes, it's visible.
Okay. Now, before we start to learn about Docker, Docker is a technology. It is a technology which deals with the containers and images, applications in form of images. So what is about container uh, and the images? See, a container and images like something, it's like hunger and food. Container is hunger and the food is the image. When you are hungry, you will consume food, you will take food. Okay. So whenever there is a need for your images or your applications to be available as an object over the internet, what you do, you put that as an object and your application as an object, which is an image, into a container. It is like simple as that. Don't think much beyond that. Think of a container. Is the container, why container? Why? Because it is like the cargo ship. You have seen the cargo ship. Okay. A big ship containing a lot of containers. It is getting shipped from one port to the other port. And what is inside the container? There can be lots of items. It can be, let's say one container is one item. Let's say rice, bags of rice is getting shipped from India to say some other country. Okay. So India is a rice bowl. You can say that. Let's say India exports a lot of rice to the other countries. So that rice is nothing but that image, and that ship is the docker. The ship which transports that rice, that image from one country to the other country is the docker. And what about the container? The container is the box or the big containers which will carry that particular rice, which is the image. So what we see, just instead of going through lots of details of what is what, I can just say that it is simple as that. This is a container, right? This is a container. Container. This is Docker, which is the ship. And this is, what is this? This is the image inside the container. In our case, this is the rice. This is the ship. This is the container. I don't know what you can say, the basket, which carries the rice from one port to the other port. This is the entire concept. So what you did, you put this as an object inside the container, which is also an object. It's a software object. The container is also an object. And Docker is the technology, the vehicle through which these objects will work. Okay. Now, so I can say I'm embedding. You are embedding an object within another object. So this is a bigger object. This is the bigger object, and this is the smaller object. See, it is like the relation between hunger and food. Okay? Exercise and health. These are related, isn't it? So similarly, it is the container versus the image. Any question, please let me know. And what is an image? In our software terminology, it is your application. This application can be what? This application can be your Java application, PHP, you name it, C++, C hash, whatever. You can Python, any application, any web application, any whatever application it is. Okay? And these applications are microservices. It is not one big bang application called monolithic. We have long left this monolithic world of applications. We have left it. We have stepped into microservices application, and that was possible because of your containerization. Any question? This was simply possible, microservices was possible because microservice applications can be contained within a container. And a container is a dynamic object. Whereas your image is a static object. You understand that? So unless you combine that or you put this into a dynamic object, your application or your image will not run. To run your application, so an interviewer is asking, what is the way that you can convert or start running your application as an image? So you will say, we will simply build it within the, or rather, we will build an image through a container, and we will make the container run. We can run the container, we can stop the container, we can remove the container. Because it's an object. You can run an object, you can stop an object, you can start an object. If you can stop, you can start. You can keep it running in the background. Yes, you can. Because it is an object. This object is a bigger object containing a static object called image. And the combination of these two will make your application run. Your application will run simply because you have made a combination of this and that. Any question? Please let me know, because without your questions, I do not know whether you are getting it. Okay? No questions. Okay. So I will remove this diagram and continue with the next slide. Now, this is a very, very important diagram for your knowledge. What is inside? What is happening inside? Though I will tell you that we don't have a scope much to go inside much more in details other than our paid trainings with a long term, that 7 weeks training. It is not possible to go into very much details inside this. But anyway, we have designed this slides in such a way that it will be easier for you to know in a very short period of time what is happening inside. So this is your Docker containers. It is saying thin writable layers. So you write within this container the image in form of layers. There will be a base layer, the base image. This is the base image. Can you see? With this base image, then you can add, this is layer 1, This is layer 2, layer 3. Think this is the container. This is the container, the box. And these are the various layers of the images. Now, what we will do, there is a Docker hub. Docker hub is a repository. Docker hub. Like you have the GitHub, similarly, you have a Docker hub. GitHub is for the source code, where you can store your codes, your files and folders and your images. Images like the photos, but here the images are Docker images. You can store over here all the Docker images, the applications in form of an image. You can store it over here. And what you do to get the base layer. So can I ask you, what could be the base layer of any application? So you want to run an application, right? So let's say this is a Java application. This Java application can have several layers of images. But can I ask you, what will be the base layer of an image for an application like Java? This can be Python application as well. Let's say you are building a single image of a Java application in layers. So what will be the base image? What do you
An
think will be the base?
operating system.
Yes, fantastic. Any application, whether Java, Python, C++, anything, will need a support of your operating system. So this can be Ubuntu, an operating system. This can be your Windows. This can be your Mac. This can be a Red Hat. Whatever the family, whatever the distribution of the Linux. This is a Linux. You can say Linux operating system. So on that base image, so what is this? This is the container. This is nothing but a container. Okay. And one of the base layers you have downloaded or pulled in an image. You are pulling an image. So what is the image that you have pulled from the Docker Hub? There are many ready-made images. There can be Windows, there can be Ubuntu, there can be Red Hat, there can be SUSE, there can be CentOS, you name it. Whatever you want, even Java as an application, as an image will be available over there. Python as an image will be there. Anything that you name it. So what you do, you are downloading a Ubuntu. So let's say this is Ubuntu. This is Ubuntu. After that, what you build? You go inside the container. You get inside the container. You go inside the container. Because a container cannot be empty. Cannot be empty. And what do you mean by empty? A container can only be an empty container when it does not have any layer of image. Basically, there is no image. So a container without an image cannot exist, does not exist. So no image, no container. Now you have at least one image, the base layer, the base image. So the container has taken a shape. This is like water. So what is the container? If you have an analogy, if water is the object that you sort of consider that as an application, what will be the application corresponding to it? So what this object is? This is a container. So you can use the container like this is a glass of water, or a water bottle. So what is that? This glass or a cup of water. If you are drinking less water, that's okay. So cup of water, a glass, cup, water bottle. These are the container. So the container is only in use when you have a water to fill in or to put in, isn't it? So once that the container has taken place, that is, it has taken a shape, you can go inside the container. You log in to the container. You get inside the container. There is a way. Okay? And once you log in, then what you do, you install a layer, a web layer, a layer of web server. Let's say that web server is Apache. So you have installed a layer of web server. So you have installed maybe Apache. Apache is a web server. Why? Because you want to have the Java application, which is a web application. Okay. Now, what can anybody tell me what could be the next layer that you want to install? You install this. You are in the same container. On the top of your operating system, the base image, you have installed the web server. Yes. Because the web server also needs the support of your image, which is operating system, any operating system. Now, what will be the next layer? Can anybody tell me?
Your application.
Let's say I need a compiler, isn't it? Don't you think? I have a Java application, yes, but I need the Java itself as a compiler. So will I not install Java? And then I will get the source code of my developer who has developed this Java application. On top of it, I will deploy it into the container. So what is this image? This is a Java application image inside a container. I can create this container and I can name this container as well. Say it's a Java container. So one application, maybe Java, this application will have lots of functions, and I will say one of those microservices, Java application microservice. One microservice I have installed. Maybe there is another container where I will use the same process, base layer, web server, Java, and then another microservice layer of the application, Java application. Okay. These two containers will be linked up because these two microservices will talk to each other. Is that clear? Any question? Now, apart from that base layer, apart from this base layer, this container always also, whenever you create this container, you will see that there is an internal kernel. You are already creating a container with an inbuilt kernel, inbuilt. This is not what you have installed. This is the one you have pulled from where? From the Docker Hub. This one you have installed. This layer. And this one also you have installed. Right? What about this? Did you install this? No need to install. No need to install. This is whenever you create a container, this particular, the green one, can you see the green one? This one is already inbuilt within the container and it is called the kernel of the container. What are the components of that kernel? It is the C group, a very important concept. When we learn Kubernetes, you will understand the importance of this when we install Kubernetes. Okay. you will understand the importance of the C groups. Because what is the difference between Docker and Kubernetes? Can if anyone has a knowledge? We will
I
learn
think when
about
it comes,
Kubernetes. Yeah, tell me.
yeah, when it comes to Docker, I think we're just housing certain services or applications or whatever, depending on what you have inside that container. But when it comes to Kubernetes, I think it is meant for the orchestration of those containers. It
Correct.
more like
Very good.
you're able to control. Yes.
Docker technology is a containerization technology, right? Docker is one of the companies. Docker is one of the technologies. There are others like Mesos, Rocket, RKT. These are, but they are no way comparable to Docker. The Docker is so popular. Many of the operating systems nowadays are coming directly inbuilt with Docker. Okay. Anyway, so that technology is a containerization technology. That is the base technology. Containerization technology. And Kubernetes is a platform, a container orchestration tool. It is, you can say, an extension to the containerization technology. It is a container orchestration tool. That means you will have lots of, this is a Kubernetes cluster, and you have lots of Docker containers, hundreds and thousands of containers in this running inside the cluster. So somebody must be there called Kubernetes who will manage the operations of these pods. These are called pods. We will come to know about this. These are nothing but the containers, okay, having various microservices. And now, so this is a byproduct or the product or derivative from the Docker technology. Yeah, okay, that's okay. I grant it that you have built your container out of Docker technology that you have known. But who is going to manage this entire service mesh of hundreds and thousands of microservices running inside the pods or containers? It is Kubernetes. So that's why Kubernetes is called the orchestration tool. It is like you have seen a Jubin Mehta program. He is the maestro of a Philharmonic orchestra. It is not only orchestra, it is something more than orchestra. Okay? So Philharmonic group. So Jubin, who is the Jubin Mehta here? So this orchestra is nothing but you can compare this with your Kubernetes. So that Kubernetes is that orchestra, the music group orchestra, and one maestro is there who is standing in between, in front of the entire, let's say hundreds of pods or Docker containers are working as musicians. So somebody is working on the guitar, somebody is working on the violin, somebody is on the flute, so many saxophone, so many instruments are playing but they are very harmonic. They are all coordinated and conducted by this maestro. This maestro is the orchestra master, this Kubernetes master plane, the controller manager, and this individual pods, which are the individual instrument players, are all the containers coming out of Docker. Okay, so these are the pods. These are the musicians. Kubernetes is the entire harmonic group. and the master is the controller, the master plane, the controller manager. Okay, anyway, that is different question. Now, just to understand that Docker is the core technology of Kubernetes. Now, what about the C groups? C groups manage resources and namespaces to isolate and secure. What about the individual images, individual layers to secure them? C groups play a role in containerization solution like Docker and Kubernetes. So you have to know that Docker, within the container, you have the C group, which is the manager of all the resources and devices, where they control container resource allocation. How will you manage the namespaces? So many things are there. So how will you put in one layer into one namespace, and all those stuff are being conducted by the C group. And especially that is very important, not only within the container, but it is important in respect to the Kubernetes cluster in a larger way, in the broader framework. Any question from here? If not, I will just remove it, right?
Just a small question, sir.
Yeah.
I've always wondered, it might sound silly, but I've always wondered, what is the difference between a kernel and an operating system when it comes to the situation?
Kernel is always the core, okay? Like if you consider the operating system, you know Ubuntu, you have learned Linux, right? In our DevOps
Yes,
course.
yes.
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 So in this operating system Linux, you have a kernel. It is called the OS kernel. Like you have seen a coconut. You have seen a coconut. There is an
Yes.
outer shell. And there is a very nice pulpy inside, the watery and soft. This is the kernel. This is the shell. These are the two intrinsic layers of an operating system. This is the kernel. This is the shell. Okay, the inner layer. The inner layer. Kernel will manage all the devices and all the peripherals, your network. Whatever management needed will be conducted by the kernel. So that is the core. Without this core, you will not have an operating system. It is equivalent for Linux. It is not only for Linux. It is for Windows. It is for Mac, or you can name any operating system, big or small. Everything will have a core kernel and supported by a shell. Shell is like a protective layer. Like in a coconut, you have a very hard protective shell, which will protect the kernel from external and malicious usage, right? So that is the shell. The shell will filter down your commands and will only allow the valid commands to get inside the kernel. For the kernel to operate on various I/O, I/O means input, output, and all these operations, and managing the devices. It's a manager. It's a manager. To access your manager, you need to access your shell with some valid instructions. Okay. Similarly, here this is a general thing for all the operating systems. Whereas there are many containers. I will tell you, there are many containers which does not have a operating system as the base image. No OS. Yeah, you can have. I can have Nginx. Nginx is a web server, just a container having Nginx without an OS. Because I will use this image on top of another image, or I will pull this image without an OS. So that's okay. That's okay. So, but still this to work, this Nginx needs to work on some support. I will have in this container a inbuilt kernel. This is not an operating system kernel. This is a container kernel. Did I answer your question? Because I still need to manage
Yes.
my namespaces, my devices, or rather resources. Better to say, to manage your resources, you need some guy, and this guy is the manager of any container. Whenever you create a container, this is by default. And this kernel actually is consisting of C groups, namespace, device mapper. So this is very, very internal to the container. You may, just for your knowledge, you have got this. Okay, these are the resource manager that has to be there. Is that clear?
Yes, it's clear, sir. So meaning that when it comes to, let's say, now you're trying to build whatever application that you're trying to ship into that space. So when we're dealing with the compute power and all those other specifics, it is handled by the kernel or the
Exactly.
shell.
Exactly. See, these layers, how to manage these layers? Because this is one layer on top of the base image. This is another layer on top of the this layer. So how to communicate between these images? I do not have any mechanism other than the container inbuilt kernel, the C groups. It will manage between these images. That this image or this particular part of the layer of that image will not crisscross to the other layer. So no layer, these layers are independent and they can be managed separately. Okay, they will never cross the line. It is like the orbit. So what is your orbit? This is the sun. Your earth is orbiting. This is the earth. And the earth is also being orbited by moon. They are in their own places. Okay? So there is some external agent called gravitational forces of large objects which will allow them to rotate in their own orbit. They will not crash on. This moon will not fall on earth. This earth will not fall on sun because they are kept separated in layers. Similarly is the case with this. Okay, so somebody has to manage this. These are the forces. These are the the components of the kernel, which will help maintain all these the image layers into their own namespaces, internal namespaces, such that they do not cross the line. They do not jumble up with each other. They are in their own orbits. Could I explain that concept?
Yes, sir, you have explained it. Thank you. Thank you.
Great. So I will remove this part and move on to the next slide. So the Docker image versus container. So you have this Docker image, and you can put that image into multiple containers. It's not that if you can have only one image inside one container. No. You can have in multiple containers the single image. Okay, You can put it here, here, here. They can all run in the same namespace, or rather in the same, node. Basically, these are working on your servers, on your nodes, worker nodes. So they can remain on the same worker node, but with the different containers. So this container, two containers cannot have the same name and the container ID. They will be different. But your Docker image, this single Docker image can exist in multiple containers. I can put it there. So I will not go into details of virtualization, difference between virtualization and containerization. Virtualization was an earlier concept. So the concept is still valid, like our laptop. We have a Windows laptop, right? Let's say this is our laptop. This is our laptop, and we need to partition it virtually. I would like to, this is Windows. I want to work with Linux operating system. So with 3 terminals of Ubuntu. So what I do, I will partition this virtually. I will have 3 virtual machines of Ubuntu. This is done through virtualization. Like I can have VMware, VirtualBox. There are many other like VMware ESXi, Oracle VirtualBox, Microsoft VMware these are the hypervisors. So you will install a hypervisor on top of your operating system, host operating system. Let's say this is Windows or Mac or Linux. On top of this, this is your laptop. This entire is your laptop, and you would like to partition it into, let's say this is your Ubuntu. This is your Red Hat. This is your Mac. You can virtualize your machine, the bare metal, into the various operating system. Why? Because you need several applications. One application is running over Ubuntu, another application is running over Red Hat, and another one on Mac, and maybe some application is running over Windows. So I need to have 4 applications running. We're needing some. They were ported with several separate operating systems. So what we will do, we will partition the same laptop into, or the same desktop into, several other virtually, like this will be a particular machine. This is another machine. This is another machine. But actually, it is one single machine. So it is called virtual. But the problem is, every partition you need to install the operating system fully. If I want to have the full version of Ubuntu installed over here. So this small application, let's say this is a Java application running on Ubuntu. This is a Python application running on Ubuntu, and this is a PHP application running on Mac. I need 3 applications, okay, various other operating systems. That is how it was ported. But I need the full operating system over here. Even if it is a very small application, I need the full installation of Ubuntu, full installation of Red Hat, full installation of Mac. So can you think of this application, how much heavy it becomes? It becomes very heavy. Why? It can be 2 GB. Actually, the application is itself 30 MB. But because of the operating system, finally the application becomes 2 GB. Maybe this is 3 GB because Red Hat is quite big. 3 GB. and maybe this one is 1 GB. Okay, and your total Windows laptop, this is like have 16 GB, 16 GB laptop memory. Okay, that's fine. So you are fine with this 2 GB, 3 GB, 1 GB. So it is total 6 GB out of 16 GB. That's okay. But still, when you pick up this application and try to port into some other platform, this is your desktop or laptop. You want to put this into a server. You want to port it into a server on a cloud. So how much of the application size that you have to port in? You have to port in full 2 GB. And there becomes the hurdle, the bottleneck, because the more and more the size is, more it becomes non-portable. You have to do a lot of configuration over this server. You have to do a lot of configuration to customize the environment to make this application portable into this server. Are you getting me? The hurdles. It is very good. It was at that time, almost 20 years back or 15 years back, this was the only technology available. But now we have migrated to containerization. Are you getting me? This containerization
Yes, sir.
is, yeah, hello. So you have the same hardware, you have the same host operating system. This is the host. It can be Windows, it can be Linux, it can be Mac, whatever. Host. So this hardware can only work with the host operating system. But instead of the hypervisor, you are installing the container engine, which is in case you are using Docker, you will install Docker. Now, can you see the same Java application? This is Ubuntu. This is Red Hat. And this is Mac. Or let's say this is Windows. And what you do, this is still Java application. This is Python. And this is PHP. These are the applications. But do you see the OS? OS has been taken out, or we can say you have virtualized. You have virtualized. You have made this OS not needed. You have virtualized it into only the requisite amounts of binaries and libraries. So this application, let's say this Java application is, as I told you, this is 30 MB. So it will remain 30 MB plus some amount of binaries and libraries that is absolutely needed only for this application. So you can add another 5 MB. So 35 MB in total. Can you compare 35 MB with 2 GB? No comparison. This is not even 100 MB. So it has become the same Java application is now running on a very lightweight support of the operating system, because you have virtualized your operating system. That is called container. You are creating a container, one container, Java container, having the Java image. Here you are creating a container, Python container, which is having the Python application. Here you are creating the PHP container. But they are, let's say, this is 35 MB, this is, let's say, 100 MB, and this may be, say, 20 MB. So now, can you compare 30 MB, 35 MB, 100 MB, 20 MB with respect to 2 GB, 3 GB, and 1 GB? And this becomes very, very portable. Why? You have taken out the OS, because the main hurdle is to fit in that OS into the environment of the server where you are putting it in. So this portability becomes very, very easier because you have minus the OS. This is just simply the application, the image, the container. The container does not need any environment configuration on the server or on the platform where you are putting in. So environment dependency is taken out. Dependency, sorry, it is taken out. That is the biggest hurdle, the nightmare of any operations team. This nightmare of matching the environment or configuring the environment according to the application demands have gone. Nightmare has gone. You do not, an operating system guy has, an operations guy do not have to do anything. Just follow one or two commands given by the development team or the DevOps guy to just deploy this container into the server environment. So just deploy it. Deploy the container. That's all. Your container is a running image, it's a dynamic thing, so it can run the image. So the Java application can start working from the moment it was deployed. You do not need to configure your environment additionally. Is that part clear? Why you will prefer containerization over virtualization? It is very simple.
Yes.
Don't think simply. You see, I always insist my students should always think simply. Don't complicate things. And when can you think simply? When you have a depth of knowledge. See, when a person starts thinking complex, because he does not know the internal working of that technology. So he thinks on the periphery. And once one starts thinking on the periphery, things gets complicated. Because he thinks, no, this will not work. This I have to do lots of. So he starts adding layer to the logic. So the things gets complicated. Whereas if you had learned the core technology very well, you know, things get simpler. Can I remove this? So it is the same thing that we have talked about. A revolution in application deployment. With containerization comes revolution in the deployment. Now you can do the deployment whatever way you like, because unlike the virtual machines where there is the OS, you do not have the layer of OS at all. So now you can play around. It is your open field to play. That is why you have microservices nowadays. You have this microservice 1, microservice 2, microservice 3. And you can have hundreds of them, thousands of them, thousands of microservice. And what is a microservice? It is an image, an application inside one container. And it's the thumb rule. What is the thumb rule? One image per one container. Never try to put in multiple images. Let's say you should not have Java application, which is an image, as well as the Python application in the same container. Never create one more container for Python. So one image, one container, always like that. So you can say, if I have 1,000 containers in my cluster or in my orchestration environment, you can say that there are 1,000 microservices. or 1,000 images working on top of the Docker engine. That is a big advantage. So you see, this Docker images is a couple of MBs, whereas the virtual image is couple of GBs. Containers take seconds to start. Containers are very lightweight. So the more and more lightweight your application becomes, your container becomes, it is very easier to start and very it doesn't take much time to start. It takes seconds, whereas it can go up to minutes. So you can see that something is running round and round and round. So you will see a revolution, that is, this is going on. There is something coming round and round and round and round and round till your virtual machine or your application within that virtual machine starts. It takes a lot of things, and this is a wrong thing. It is earlier it was not compatible with Linux distributions, but nowadays you can have your containers run on Linux. Of course, it has to be. Virtual machines are compatible with all the OS. This is also true for all the OS. And similarly, this is, you see, you have a Java application deployed over Apache Tomcat. This is container one. Another application is a .NET, Microsoft .NET application. You have deployed it over, and you are having another layer of image called SQL Server. So this is a database application. It's a web application. And this MySQL and Python, this may be on a different platform, I mean the operating system, but this is another database application. The front end is Python and the back end is MySQL, is a database server. So you can have various combination of your containers. Whereas here, this is also, it is just giving you application A is nothing but Apache Tomcat and Java, and there is the requisite binaries and libraries from the operating system. That's all that you need. So before containerization and after containerization is the deployment, and the operations team were at a fix. They were having nightmares, as I told you. They were, if you are going for virtualization deployment, and then that means they have to give you an artifact, an instruction manual for the operations team. See, operations teams are not very good in your, they know their process, but outside their specifications, they cannot work. So it will be very difficult for them to follow the artifact and instructions coming from the development team to configure the environment. So basically, they fall back on the development team again and again, and as if they are totally dependent on the development team. And the development teams play around with the operations. I have seen myself how the development team bullies the operations team. That is a very bad thing for any organization to happen. You should not play around with another person's ignorance. You have to train them up. That is the best employee. You will get the best employee of the year or the month only once you start thinking in those terms. You should not undermine the potential of a guy. Maybe at that point of time, he does not know that technology, but you have a responsibility to let them know the technology. So sit with them as a DevOps guy or a development guy, sit with the operations guys and let them understand the entire flow. Don't bully them, because that will bring down your, you will be actually not be liked. You are not a friendly guy. And DevOps, why we learn DevOps? Because we want to bridge the gap between the development and the operations. Okay, so we will never undermine the potentiality, and we will always try to thrive into the excellence for getting the excellence of the operations. Okay, to automatize the processes. You have to work with the operations guys. So don't make their lives are already very skewed or screwed. Okay, so let us work to make their lives happy. And that is the best way that you can do with the containerization technology. That is, Docker, and let them also learn a bit of Docker, such that everything you just have to give a little bit of instruction, just one or two Docker commands. That's all. You give the Docker file to them, and you just ask them to run this Docker command to work on this Docker file, and just giving one simple command, the entire image or container will be deployed into their test environment or pre-production environment or production environment. Can you see the application of containerization? Any question? Anyone? Can I move ahead? So we have understood that before there were lots of problems before containerization. So we will try, try the VM that I'm working in. So I'm giving the developer is giving the virtual machine all together to the operations team. But the operations team is saying that could break another code in the testing on the production server, because I'm not only dealing with your application, there are lots of other applications from other projects also. So how can I manage that? Please do something about it. I cannot take your virtual this thing. So there is a tussle between the development and the operations team. Uh, but after containerization, what the developer is saying that, see, okay, I understand your pain point. Okay, understand your agony. I understand your problem. So what I did this time around, I have wrapped up my code inside the container, and I'm giving you a very lightweight container to you. You just have to run one Docker command and you are there. So how good is that? So there is a big smile on the face of the operations guy, and they said, "Oh wow, it is only hardly 30 MB. Awesome, your code works just fine." Why? Because he had executed that command given by this DevOps guy or the development guy, and he does not do anything. No configuration changes needed in the testing environment or in the pre-production environment or in the production environment. Just one line of code this guy will execute. Any question? Applications are transforming, as I told you. This is a monolithic. There you need a big server, and there were lots of functions, but all tightly coupled within one monolithic layer, one single layer. Mono means one, and lithic means layer. Are there people around? Let me check. Yeah, there is less, but that's much more than our expectation. That's very good. Thank you. So I think I have half an hour. I can best use that time. Can you see the screen? So you need a very robust and a big server to host your monolithic application, because that is a huge application. All the separate functions are all tightly coupled with each other. Any one of these functions failing, the entire application will come down. You cannot pick it up. Let's say you have got a issue and you wanted to, there is an issue in this particular function of this application. You wanted to pick this up separately, let the application run. No, it will not. Once you pick it up, you have to shut down the entire application, because otherwise you will not be able to correct this particular part. After you correct it, you correct it, you have to build it, you have to test it, and then you have to deploy it. So there are 4 stages that you have to do. And while you are doing this, you have to do the regression testing as well. Because if you have changed the function a bit of this particular unit, you have to see whether the new change that you have put in for this function is impacting the other functions which were running fine otherwise. So you have to do a regression testing as well. This is the integration testing and the regression testing as well. So you will, so till this time, this everything is happening, the entire application is down. You cannot keep on running. Let's say this is the same application. Now in the microservices world, you will single it out, do the correction, and put it back. Put it back in the environment. What happens? Did you make it down, 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 down? No. They were all running as it was. So nothing happened to the running application. The application was still running. Yes, this functionality was not available till you have done the correction and you have put it back. So which one will you go? And also, you can have your replicated microservices in small servers, server 1 or the node 1, node 2, node 3. This is an expensive machine and big machine. So there is always, you have to employ someone to take care of this. Operations is costly. It's very costly. Whereas these are small machines. No need, because your applications, your microservices are very small. So you will deploy all these microservices and replicate it. So let's say there are 25 microservices deployed. You can deploy the same replica, 25 microservice replicate. You have the same. They are working in the same cluster. 25. Okay, it is as simple as that. And if you put that into a Kubernetes cluster, all this with the 4 nodes, then whenever some function goes down, some pod goes down, it will be immediately replaced and replicated over here as well. So which one will you go? Are you going to go for virtualization or containerization? If you ask me, I will always go for containerization, because that is the way the world is moving to. So this is the same thing, that you are breaking down your monolithic application into microservices. Microservices, breaking application into separate operations, and of course, to create a microservice application, but though it's a development activity, but you know there is a 12-factor applications, like the for any, you know, for RDBMSs. RDBMS. Just few moments back, when Karthik was describing MySQL and the vulnerabilities, how to hack, there is the SQL injection. So in that case, also that is an RDBMS, okay, relational database management system, and there is you cannot create a RDBMS without following the CORDS rule. Similarly, there are 12 CORD rules. Whenever you want to describe that this application is an RDBMS, so it is saying that you have implemented the 12 CORD rules for making an RDBMS application. Similarly, when you are creating a microservice application, you will have a 12-factor, so you can just find out from your Google what is a 12-factor application. What are the 12 rules or 12 factors that you need to consider when you are trying to design a microservice application? Okay? You have to design it according to the 12-factor rules. But that is a development activity. You do not, as a DevOps guy, you are not concerned with it. You will not be concerned. You are concerned in deploying it correctly over onto a Kubernetes cluster or any environment. Okay? Correctly. And automate it. So I will quickly go through this. Here you have the developer. Developer uses a GitHub or a version control software system. There will be a build server which will automatically build the source code. And then the container, the containerized application, that means you are trying to build it as an image through a build server and put it into the container. This is a container, but a build can go wrong. Okay, you will not be able to end up building a correct image. So what you do, you send it back with a warning or whatever to the developer. Developer corrects it, and then now the automatic build happens, and this build is correct. So you will put it into a repository, whether it's a Docker Hub repository or some other repository. Like in DevOps, you have a repos. I mean, Azure DevOps, you have a repos, so you can put it there. In GitLab, you have a GitLab repository, whatever. So there is a lot of repository for that image. Now, then you will put this into a QA or QE environment. Okay, quality assurance. So in that means you are putting into a test environment where your code will be tested. These are all through the pipelines. And this is possible because you have containerized your application. You are putting that container into your redeployed to your testing, pre-production or production. As simple as that. So the development, second stage is the test, and the third stage is the staging or the production environment. So you do the application delivery. This is called the delivery. There is a history of the container, Docker. I will not go through it because that is not very important. We know Docker has a lot of history and why it is so popular. So Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure. So you are not dependent on the infrastructure, on the platform. Platform independence is what you want. So you can deliver your software quickly. Platform, you want to get rid of the platform or environment independence. Platform independence. With Docker, you can manage your infrastructure in the same ways you manage your applications by taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly. That is, the quickly is the term. You can significantly reduce the delay between writing code and running it on the production. You write the code, you commit it. See, you code. Once the code is completed, you commit it into where? In your GitHub or GitLab or Bitbucket or Azure DevOps, repos. So whatever you do, you are putting them into a separate where you store your code. So you commit that. Once you commit that, the pipeline that you have created, the automatic, you will automatically trigger the pipeline that you have built. Now the pipeline could be on any technology called GitLab or Jenkins or Azure DevOps. Whatever the pipeline is that you have built in, it will automatically trigger the pipeline. And what will the pipeline do? Pipeline will continuously integrate, continuously deliver, continuously deploy. Integration is building. Delivery, this is continuous delivery is release. And this one is deploy. You deploy it to your test environment or your pre-production environment or to this. This is all done automatically through the pipeline. And in the meantime, you have your Sonar Cube, which can test the quality of the code, and so many other stages you have. You will have an approval stage, that whether you want to go ahead delivering it to the or releasing it to the test environment or whatever. Then there will be a testing, and then when everything is fine, then there is again an approval process. And when the approval is there, you will deploy it to your pre-production and whatever. And that is all possible because you have containerized your image, your application. Any question? So long time you have been very quiet. Yeah, that's okay. That means I am very happy that you are understanding. So the last thing is, Docker provides the ability to package and run an application in loosely isolated environment called container. Loosely isolated environment and called the container. So you have the ability to package, build. Basically, you are able to build it as an image, your application as an image, and put it inside a container. The isolation security allow you. Now this is your DevSecOps. The cyber security. The security that within the container is very important because you have created the container with the DevOps technology. You have created the container. But who will provide you with the security? Now we will learn DevSecOps. The same container will be now secured. It will allow you to run many containers simultaneously on a given host. So on the same platform or on the same node, you are running hundreds of containers. Containers are lightweight. That is the most important part because they don't need the extra load of a hypervisor but can run directly with the host machine's kernel. That's all. It will take all the OS inputs from the host machine, whatever required for the container. That's all. This means you can run, you do not have to package the OS within the container. No need for OS inside the container. Because whatever little bits of binaries and libraries that is provided between in the host operating system will be more than enough for your application to be running inside the container. This means you can run containers on a given hardware combination that if you were using virtual machines. So any given hardware combination, no problem. I can use it. I can port it directly over it. No issues. You can even run Docker containers within host machines that are actually virtual machines. Okay. Now, this is the most important part is what is the architecture? The architecture is very simple. It is like the kernel of the operating system of the Linux. The outer layer is the shell or the Docker CLI, where you put in all your Docker commands. This is your interface. That's why it is called CLI. Command line interface. So you as a user will give the Docker commands. You will write the Docker commands in this layer. You give these commands. These commands will be thrown into the REST API, another layer. The REST API will filter down your commands and check whether the syntax and everything, and it will make, if everything is fine, it will make a call to the Docker daemon through the REST API, the server. And the server is called the Docker server or the Docker daemon. Daemon is something which is running as a service in the background. So this is the actual engine. This is the Docker engine that you install. And while you install the Docker engine, you will also install the Docker CLI. It comes together, the REST API. Everything will be installed along with when you install Docker engine. When the command reaches this Docker, then now similarly to kernel, like the kernel manages, or the kernel is the manager. So Docker kernel is nothing but the Docker daemon, which will manage your network, it will manage your container, it will manage your image, it will manage the data volumes, the Docker volumes. Volume is a storage where you can persist your data or from the container. Otherwise, the container is what? Container is itself ephemeral. Ephemeral means the containers are very temporary. It cannot store or persist data permanently. So to do that, the Docker has given you the Docker volumes, which with the help of which you can be able to store your data permanently. Even if a container goes down, or the volume will not be deleted or down. The volume or the data is still all intact. That is these are the three components: the server, which is the Docker daemon, the REST API, and the command line interface CLI. Any question? So the Docker workflow is a very similar thing. That is, I will remove this. You will use the Docker client. Like these are the commands. Okay. You are using that CLI, the Docker CLI. And this command will through the, what is that? REST API, through the REST API. REST API is a very important term nowadays. So you call the Docker daemon. This is the Docker engine. Installed onto an instance, on EC2 instance or a server. This is a server. In AWS, it is called EC2 instance. You have installed you can install your thing on your Windows or on your Mac. You can install the Docker. Or you can install it over on any server having Linux. Okay. So what happens when you say Docker build? Now it will reach the Docker daemon through the REST API. And Docker daemon, what will it do? It will go to the Docker Hub registry and it will pick up the base image. Let's say this is Ubuntu. You have given a build command, and through this base image, which will be here, sorry, this is here, and this will be then containerized. You have pulled it from the Docker Hub. This is the Docker Hub. This is the Docker Hub, and from there, this image will be downloaded and pulled, and this image now will be containerized, or you will create a container out of this image. You can put that into multiple containers. Okay. And once the container is there, you can get inside the container and go inside the container, as I told you earlier, and you can create layer after layer within that image. So on top of the base image. This is the overall flow. Any question? This is, I think, this is the CentOS. This is another operating system. It is Linux. It is Linux operating system, like Ubuntu. No question? So these are the various components. I will end my session today. Just saying this. This is where you pull your image from the Docker Hub, put that into the base image of a container, and add one more layer. So then this becomes the same container, but you have added one more layer. So you can keep on adding layer after layer after layer after you have done the base image. Okay. And you can run your container, you can stop the container, you can delete the container. These are the containers. You cannot run an image without the container. A container, they are mutually exclusive. So a container and an image, let's say this is an image. So image, container, they are mutually exclusive. Sorry, mutually inclusive. That means one cannot run without the other. They are in love with each other. Okay? They cannot exist without the other. If I cannot have a container which is an empty container. I cannot run an image without a container. So they are mutually inclusive. So you have, these are the components, Docker Hub, then the Docker engine, and we have learned about Docker images. We have learned about containers. This is a part of the software environment. And then we have also learned about or understood that there is a component called Docker volume for persisting the data. And there is one very important thing in Docker called Docker file. It is a manifest file. A manifest file is a very important file in any DevOps configuration. Manifest file is you try to say what you desire. What you desire is put it into a configuration file called manifest file. So a Docker file is a manifest file through which you can build your image. You can create an image, build an image out of development source code. Because the developers have given you the source code and you will do something through the Docker file to manifest, to desire an image out of it. Okay? So this is all for today. So I think you have got a bit of idea on. So we will not do any hands-on, uh, no scope, but I appreciate that you have exercised so much of patience to go through a very, very not very interesting topic, but yes, very useful topic. Because if you desire, manifest to have something, a good job in DevOps or in DevSecOps, you must learn Docker. There is no other way. Thank you, gentlemen. Thanks for a lot for your patience and for your, uh, you know, perseverance. Thanks a lot. Mr. Menon, are you there? So anyway, it is already a bit of time, and it's quite night in India, and I think it's morning time your place in US. So anyway, we will stop the recording. If you have any question, please let me know. I will not put that into recording. Sometimes you may find it uncomfortable that something is getting recorded. So I have stopped the recording. Now you are free to ask any question if you have. I will stop my camera as well. So we are going to learn all these things, quite lots of details in our actually the job ready training, the paid course that we say. This is just an overview. This is just to make you aware of what is the technology and what is something behind the technology, so that you grow that interest of learning a new subject. Maybe it's a new subject to you, or may not be. But whatever it is, it will help you to understand and work through your roadmap, whether you will like to get. And I can tell you, if you are not from an IT background, this is no other way you cannot step into development, because development world is so matured and so saturated that you need to be a genius to get a job in development. You cannot go into operations or testing without knowing DevOps. That is as simple as that. Because you cannot directly go into a database administrator or a Linux administrator or a system administrator, because those are very, very specific roles. But yes, you can apply for a DevOps job because you do not know in and out of the system, but you know the tools very well, the DevOps tools very well. So you can be a valuable asset to any company who have implemented Agile and DevOps processes. Okay? And of course, because a topic is coming up very fast in the world of cybersecurity is DevSecOps. And to learn about DevSecOps, you cannot jump into DevSecOps. You can if you are a genius, but everyone is not a genius. Okay? So I will suggest you come to DevOps, learn DevOps, the tools, create your assets, create your resources, and then you know how to protect your resources, as Mr. Menon was saying. So that's all for today. I think I should not be holding much of your time. I think you have enjoyed the session. Thank you very much.
Thank you.
Thank you. Thank you.
All right, guys. See you later.
Yeah. Thank you.